Hey everyone, welcome back. All right, let's jump right in. Today we are breaking down task list item B23 from the 6th edition, and that is the matching law. Now, this comes from Domain B, which is a pretty big chunk of your exam, about 14%. But, understanding this isn't just about getting a question right, it's really about getting to the heart of how and why we make choices.
So let's paint a picture. One you've probably seen 1,000 times. You've got a client, and you've got two different activities set up. They can earn tokens for doing some math problems, or they can earn tokens for some quiet reading. The key thing here, both choices are available right here, right now. It's a classic choice scenario.
So the million-dollar question is, where are they going to spend their time? Is it going to be 50-50? Are they going to lean heavily into one over the other? This isn't just a guessing game for us. As behavior analysts, we need a scientific, predictable way to understand this, and, even more importantly, to ethically design our programs so that the best choice for them is also the most likely one.
Well, the answer to that big question, it lies in this really elegant, powerful principle. You can almost think of it as a formula for behavior, especially when there's a choice involved. And that, my friends, is the matching law.
So what is it exactly? Well, the formal definition, which we get from Richard Herrnstein's work way back in the 60s, is all about this amazing quantitative relationship. It says that the proportion of responses, so the amount of time or effort someone puts into one choice, is going to directly match the proportion of reinforcement they get from it. I know, it sounds a little academic, but the idea itself is incredibly precise. But let's just boil all of that down. If there's one thing you walk away with today, let it be this. Behavior goes where reinforcement flows. It's really that simple. It's that profound. Organisms, whether we're talking about pigeons in a lab or our clients in a clinic, they don't just behave randomly. They follow the path of reinforcement.
And that's the core idea right there. It's all about proportionality. So if we go back to our reading versus math example, let's say we set it up so that reading provides 75% of all the reinforcement available, all the tokens, all the praise. Well, the matching law predicts that the client is going to spend about 75% of their time reading. The behavior literally matches the reinforcement.
And this visual just nails the concept. Look at these two charts. On the left, that's our reinforcement pie. We've decided to make reading way more reinforcing than math, right? 75 to 25. And on the right, you see the predicted result. The client's behavior, their response allocation, it just mirrors it perfectly. The behavior pie matches the reinforcement pie. It's awesome.
Okay, so this law doesn't just happen anywhere. It needs a very specific kind of environment to really shine. For the matching law to work its magic, it needs what we call the arena of choice, concurrent schedules of reinforcement. So, what's a concurrent schedule? Well, the key words you got to remember are independent and simultaneous. This means you've got at least two different schedules of reinforcement for at least two different behaviors, and here's the kicker, they are both available to the person at the exact same time. It's a real genuine choice, moment to moment.
Okay, now this slide is super important because it's going to help you avoid a really common exam trap. You absolutely have to know the difference between these compound schedules. Look at that first column. The only one that is simultaneous is concurrent. See that? Multiple and mixed schedules, they alternate. One is on, then the other. And a chain schedule is sequential. You have to do A, then B. That simultaneous availability is your big, flashing sign that the matching law might be in play.
All right, so this is all great theory, but how do we actually use it? Let's talk about how we take this from a cool concept and turn it into a really powerful tool that we can use in our therapy sessions every single day. Okay, so as a BCBA, you can think of this as a 4-step game plan. First, you've got to identify the choices. What are the options available to your client, and what's the reinforcement for each one? Second, you've got to get your data. Measure the rates of the behavior and the reinforcement. Third, you analyze. Does the math check out? Is the behavior actually matching the reinforcement? And fourth, and this is where the real magic happens, you adjust. You can systematically tweak the rate, the quality, or even the delay of reinforcement to ethically nudge that behavior in the direction you want it to go.
I mean, here's a perfect example. Let's say before we intervene, a problem behavior like yelling gets a ton of reinforcement. Maybe attention is delivered on a really dense schedule. At the same time, an adaptive skill, like using an AAC device, gets almost nothing. The matching law tells you, yeah, the client's going to yell. So what do? After our intervention, we completely flip the math. We put the yelling on extinction, or a really thin schedule, and we pour reinforcement onto using that device. We make the adaptive skill the single most reinforcing choice available. And what happens? Behavior follows that new, richer path. All right, let's put on our exam-taking hats for a minute. How is the BACB actually going to test you on this stuff? Let's walk through a typical scenario. So read this one carefully. A student has two options: work on assignments for points on a VI 2-minute schedule, or use a sensory corner for breaks on a VI 6-minute schedule. And they are both available at all times. The data shows the student spends about 3 times as much time on assignments. What principle are we looking at here?
Let's totally dissect this. First, that phrase, both available at all times, should be setting off alarm bells in your head that scream concurrent schedule. That's your context. Next, spends about 3 times as long. That's your data on response allocation. Now let's do the math. A VI2 schedule delivers reinforcement on average 3 times more often than a VI6 schedule, right? The reinforcement rate is 3 to 1. The response rate is 3 to 1. They match. This is a textbook, beautiful example of the matching law.
So, as we start to wrap this up, I want you to think about this in a new way. The matching law isn't just about explaining behavior after it's already happened. It's a tool that lets us predict behavior and proactively design our environments.
Okay, let's lock in these key takeaways. Number 1, the matching law is your formula for predicting choice. Number 2, remember its home base, the concurrent schedule, where options are simultaneous. 3, the big idea is that response allocation matches reinforcement allocation. And finally, the most important part, you can use this clinically. By tweaking those reinforcement variables, you can make the adaptive choice the path of least resistance and most reward.
I really want to leave you with this thought. The true power of the matching law is that it lets us become architects of behavior. We can finally stop just reacting to challenging behaviors as they pop up, and instead we can start proactively building environments where the best, most adaptive choice for our client is also, not by accident, but by design, the most heavily reinforced choice.
So the next time you're in a session and you see a client who is consistently choosing one thing over another, I want you to challenge yourself. Don't just ask why, ask, what does the reinforcement math tell me? Because at the end of the day, behavior goes where reinforcement flows.
Thanks for tuning in.